Okay, so let's get started. We're going to be taking a look at setting up our gear detection within our Motec M1 programming. Now there's a variety of different ways we can program and set up gear detection. We're going to be taking a look at the most basic general way to set up gear detection. That's going to require us to be able to monitor engine speed and a vehicle speed source so that we can do an estimated gear detection. This will be suitable for any transmission type. Now, if you're going to be working with a sequential transmission that has a gear position sensor, things are set up a little bit differently. We'll have a separate training module on working with that type of gear detection and paddle shifting. I'm working with a GPRP package, which is a paddle shift option package that is going to be specific for doing that paddle operation. And gear detection, again, is set up a little bit differently based on a paddle or a sequential transmission. So this would be appropriate for any manual transmission, or even could be even automatic transmission, as you're going through and trying to utilize gear for all kinds of other runtime value programming in our Motec. So we could utilize gear detection for something like traction control or gear shift ignition cut. So this could be utilized for that function to allow us to detect gear. So let's go and take a look at how to set up our gear detection. It's going to require us to first set up a vehicle speed source or vehicle speed sensor, and then we can jump into the gear detection and using this estimated option. So first things first, I'm going to move here from my general tuning window in our general tuning pages under the workbook here. So this is going to be the workbook I provided with the training course. I'm going to move into the setup area here. Now under setup, I'm going to move across here and do the speed setup. Now we touched on this in the last training module. This is going to be where we set up our speed sensors or drive sensors. So depending on what we have configured here. Now in my particular situation right now, I'm going to demonstrate how to set up a front speed source, so a wheel speed sensor in this case, and then how to go in and define all the other parameters real quickly. Again, we touched on that a little bit more in depth in the last training module. Then we'll jump into our gear detection to be able to do this estimated option. That's extremely simple to set up and work with. So first things first, taking a look in our wheel speed resources programming window right here, we have to set up our drive type. That can either be front, rear, or all-wheel drive. In my case, it's a front-wheel drive Honda. Go in here to wheel speed, and I'm going to go into front, and then in here, I'm going to go and wire everything into the left source. So this is going to be my wheel speed sensor. You could wire in and set up a drive speed source. This would be if I'm utilizing the transmission speed sensor. In my case of a front-wheel drive Honda, I chose to use a wheel speed sensor. So just real quickly, let's run through some of our programming here. So I've assigned my left front wheel speed sensor into the universal digital 3 input. So that's where I've wired the signal wire. Now my particular configuration, I'm running a Hall effect sensor. I actually got away from the VR magnetic sensors because the sensors were damaged on my vehicle. So I went in and machined a bracket, and I'm utilizing a Hall effect style sensor. This is going to be a little bit different in terms of our configuration under our pin settings. So real quickly here, I've set the pull-up control to on for a Hall effect sensor, active edge to falling edge. So it's going to be looking at the falling edge of our square wave signal. The threshold is going to be half of what we measure at the maximum voltage from our channel output. So in this case, I'm measuring almost 11 volts. I put the threshold at 5 volt. That's going to allow it to ignore a potential false pulse coming from the sensor or a bad signal. The threshold's at 5 volt. The hysteresis I've set at 0.5 volts. So it has to see at least of a difference in change of 0.5 volts then to actually detect it and utilize that as a signal as that pulse is happening. And then the debounce, I've set it here at 20 microseconds, and that's sufficient typically for a Hall sensor. So I've configured the basic details for my sensor. I went in, I counted the number of teeth that are mounted on the hub, and I set that at 30 teeth. The scaling ratio I set at 1.0. This is used as a multiplier if you want to be able to scale out your sensor if something's not reading right. I set the sample teeth at 0, so it's going to be doing an averaging effect, looking at the sampling coming from the sensor. That's typically what we use for a wheel speed sensor. And here, I've set the pitch threshold at 50%. This pitch threshold only applied if we change the sample teeth to something other than 1. So if we're at 0, it's not applied. Timeout threshold, we have to see a signal for at least 1,000 milliseconds before it starts to detect and do something. And then finally here, our final drive ratio. This is something that we're going to need to populate if we want our gear detection to work. It doesn't affect anything with our actual speed source reading here, but it is going to be applicable to the gear detection. So gear detection in the estimated mode will not work unless we're populating a final drive ratio. This is going to be literally the final drive ratio of your transmission. So in my case, I'll set this up right now, that's going to be a 4.7 final drive ratio. Now, the other thing...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.